Hello and welcome back to another Mominis Studio tutorial. My name is Tzach and I'm the Chief Technology Officer here at Mominis. In today's tutorial, we will introduce two highly useful concepts, variables and flow control. By the end of the lesson, our hero fish will be given 4 lives, or 4 attempts at playing the game. Let's start by loading mofish4.mom and looking at it in the simulator. As you may remember, we have a hero fish that can move up, down, or left in an attempt to avoid coming in contact with enemy fish that are constantly created and keep on coming from the left. Still, the way the enemy fish appear is not very realistic. They seem to sort of appear in the middle of the screen. It would have been much nicer if they appeared right outside of the screen and sort of swam into the screen gradually. In addition, once our hero fish touches an enemy, it is immediately destroyed and the game is pretty much over. We would also like to lengthen the gameplay and add lives to our player. These are the two issues we will deal with in this tutorial. We will start by modifying the position where the enemy fish appeared. We already have our Y position set to a random height using an expression. It is time to set the enemy fish's X value. We would like our enemies to appear in minus their width, which is immediately outside the visible screen. This could be done easily by checking the sprite's width and writing it with a minus sign. It would work, but is not very scalable. We would have to change the expression every time we change the enemy fish's picture or size. This is where built-in properties come in. Built-in properties are simply values given to us by the environment that let us relate to the current runtime situation. The list of those can be seen by pressing Control Space. This is the drop-down where we used the rand operation in the last tutorial to get a random number. In addition to rand, the list contains items which are written in all capital letters. Some examples are current time, room height, room width, etc. These values can be used within the expression and are automatically replaced with their values in runtime. In other words, using room width in an expression would get replaced with the actual room's width when the expression is evaluated, and current time will get replaced with the time in milliseconds the game has been running. These are useful in various situations. Unfortunately, this is not really what we need. We would like to get the width of the current sprite. When wanting to refer to properties of a specific instance, we must specify the target explicitly. As you might have noticed, in addition to the built-in properties, the list contains the supported target instances, self and father. Since we would like to get the width of the newly created sprite, we'll select self. We will now add a period and press Control Space again. The drop-down list reappeared, but this time with different values. The values include X-pause, Y-pause, and Z-order to retrieve the sprite's current position, X-speed and Y-speed to get the sprite speed, and width and height to get the sprite's dimension. For our purpose, width is the right value. We will prefix the expression with a minus sign. We will do the same in the created event. In the future, we will learn a concept called custom event that will save the need to duplicate our changes. Let's run the game. The fish are coming from outside the visible screen. Now that we have our enemy set, let's move on to adding lives to the player. We'll begin by bringing our fish back to life each time after it is eaten. So far, we have placed our hero statically on the right, near the screen's edge. Instead, we will now use the controller to create the hero, whenever it detects the fish is missing. We will move to the room designer and using the property grid, check the current location of the sprite. It is 170 by 100. We will use these values to later on create the sprite dynamically. We deleted the animated fish instance, and we will now add a new event to the controller, a number of sprites event. This event is used when we would like to check the number of instances of a certain sprite that are currently in the game. In our case, we would like to see if there are no hero instances on the screen, and so we'll select the animated fish sprite at the top, leave the expression with the value of 0, and change the condition to equals to. Like I said, this event will be triggered the moment it is detected that there are no hero fish in the game. Inside, we'll place the create object action that creates an animated fish. To make the fish appear in the correct location in the screen, let's add a move to action inside the create object node and set it to the values we retrieved by looking at the property grid, 170 by 100. Let's run the simulator, this time using the keyboard shortcut, Ctrl-T. As you can see, I now have an animated fish that reappears at its original position every time it collides with an enemy. Playing the game, it may seem that the fish is simply moved back, when this is not really the case. In actuality, the collision destroyed the hero fish, and the level manager controller took care of spawning a new fish instance. The player in our game now has an infinite number of lives. Let's add a bit of a challenge and limit the player to 4 attempts, or 4 lives. To make this work, we need some kind of a counter to keep track of the number of lives. This is where variables come into the picture. Variables are basic elements of nearly all programming languages. These can be thought of as memory cabins, which are used to store values in a game for later use. Let's move into the global variables list and add a variable. We'll call it fish count. We can also add a short description, number of created hero fish. As you can see, the default value is 0. This is good for us. To keep track of the number of times a hero fish was created, let's increase the fish count by 1 every time a new hero fish is created. We will do that by placing a setGlobalVariable action in the level manager controller right after it creates a new animated fish instance. From here, we may select the variable's new value. But wait a minute. We are not interested in overriding the current value, but instead would like to increase it by 1. Checking relative at the bottom will do exactly that. Setting the value to 1 will cause the variable's value to increase each time the action is called. Good. We now have our fish counter increasing whenever a new animated fish is created. This is all nice and well, but still doesn't do anything. This is because nowhere in our logic do we pay attention to the value of our counter. To do this, we will have to add our first flow control action. Flow control actions, as one could guess, affect the flow of the logic. Most flow control actions fall into one of 2 categories: loops or conditions. Loops enable running a series of actions more than once, without the need for making copies of them. This is useful when wanting to, for example,